start recording here. All right. So, in any general questions, just in general, before we go ahead and review for the final, any questions regarding how things work in the class, all that good stuff. Of course, we're going to meet. Yes.
So if we for the whole final grading, final grade, canceling out the one of the test grades, how's does it have to be a certain amount of a higher grade, like 5 more points, 10 more points, that kind of thing?
No, no, no. As long as the grade on the final is higher than the lower of the two grades, even if it's just by 1 point, right? Yeah, there is no necessarily, there's no how many points over. So if you get like your lowest here is like a 43, right? And you get a 50 on the final. I mean, I'm just making that up. Then the 50 takes place of that 43. Or even if it's like a 44, right? So yeah, it doesn't have to be by a certain number of points as long as it's higher. Yes, Joya?
Yeah, mine was kind of similar. Like, how should we know what to get on the final if we don't have our overall grade in the class yet? Because, like, I don't really know what to base it
Yeah,
on,
yeah,
and I'm, like, getting nervous.
right. Okay, yeah, so the only time I calculate your overall grade is during the midterm and the final. Okay, but if every student, if you have all of your grades, and I was telling somebody this earlier, you can take all of your grades and put them in Excel, right? So, like, say for example, if you know the in-class assignments and the labs are worth, I forget, I think it's like 10%. Just I forget the actual percent, but just go to the syllabus and it'll say in-class assignments, labs. So what you do is take the average. You can put those grades in Excel and do something like equals average or whatever, and just that core of grades. Then you attach 10% to that, multiply by 0.10, then get that number. Then take your top three quizzes, then get that average for those three grades, and then multiply by that particular percentage that's on the syllabus. Exams, same thing. Take the two exam grades, get that average, and then multiply by, I guess it's, I don't know, 20. I forget what the exam average is. And then once you get those three grades, you add them together, and then divide by, I think it's 75. Whatever the final exam is worth, leave those particular points off. And so when you do that, divide by 75 and multiply by 100, that'll give you kind of where you stand in the class now. But that's kind of misleading because it does not take into account the grade on the final in terms of the replacement, but that'll give you a general idea about kind of where you stand in the class. So I don't know exactly, like, for example, what grade you have to get on the final to pass the class or what your current grade is now. There is no mystery in terms of what your grade is right now. If you go through the exercise of what I just mentioned, finding, the in-class assignment grades, the quiz grades. Now you just can't add up everything and then divide by however many they are because it's different categories, right? So I mean, everybody has the capacity to do that. That's the basic kind of lesson in Excel to kind of sort of figure out where you are now, right? But I almost hate to tell people, oh, I calculated all of your grades and looks like you have to get a 99 on the final to pass the class. Well, who needs that stress, right? And more than likely that's not many of your positions, right? So if you just really have to know, inquiring minds want to know, then that's just a lesson in putting in your grades in Excel and figuring out kind of where you stand right now. But yeah, I only do it twice, during the midterm, and if I sent you a midterm warning, then at that particular moment you either had a D or an F, right? And so since then, have you done better? Have you done worse? So that the midterm, if you got one of those, or if you did not get one of those, that was a general idea about where you stood in the class. All right.
Okay.
Okay. Well, let's go ahead and knock this out. Now, in terms of preparing for the final, the good thing about the final exam, number one, there's not going to be any Excel in terms of, how we normally do like the multiple choice part, and then I give you a problem in Excel to do on Excel. So there's going to be none of that. No problem where I give you that you're going to have to do on Excel. Everything is going to be pretty much, either multiple choice, or short answer. And when I say short answer, that means if I give you, I don't know, a regression problem, and I say find the slope, and then there's just like a blank there, you just have to type in what the answer is. Almost like on this past exam, I said something like, what is n minus k minus 1? And the answer was 20, right? Then just type in 20. Now, some of you on the exam put in the word like residual or something like that. And so initially the system marked it wrong. Then I went through and I gave you credit for that. So I'll be pretty flexible in terms of, or I'll try to be real specific in terms of what I'm looking for in terms of that particular blank. But no Excel. So that's a big sigh of relief. Everything is going to be strictly, I'm going to ask you a question, or I'll give you like some printout, and you have to analyze the printout and choose the best answer. All right, so that's that in terms of format. Now you're going to need F table, T table, access to these, and the Q table. F table, T table, and Q table, and make sure you have alpha equals 0.05 and 0.01. Now on this exam that I just gave exam 2, most of the questions asked about 0.01. So don't automatically assume that I'm just going to be asking about 0.05, and the difference is just turn the paper over. Just make sure you're looking at the right side of the paper. Same thing here, 0.05 and 0.01, and the same thing here, okay? Now with this T-table, remember the T-table that we looked at up at the top, it says like one-tailed or two-tailed, right? And so mostly, we're pretty much, we're just going to be using the two-tailed. This course didn't really focus on a one-tailed test. That's more for your 222 class. So 0.05, 0.01, just make sure you go to the two-tail option up at the top. Make sure you have those. We're not going to worry about any z-tables. You remember when we started the course, we did regular hypothesis testing with the z-table. So the final is not going to have that on there. No hypothesis testing in terms of just using that z-table. The final is going to pretty much start with, let's see, and if anybody's interested, I'm just going to be going through, I just printed out the folders from Blackboard, week 1, week 2, week 3. So I'm going to kind of use that as my guide and sort of going over. So the final is going to officially start with one-way ANOVA. One-way ANOVA, one-way analysis of variance, okay? So one of the things you definitely have to do, you're going to have to, and I can't stress this enough, you're going to have to go through every single quiz all over again. Because see, it's been a while since we've done this, right? And you can recall the one-way ANOVA strategy deals with comparing groups, right? Where something like h of 0 equal, h of 0 is something like mu1 equals mu2 equals mu3, right? That whole situation. And then h1 looks like something like not all group pairs are equal, okay? Which simply means that at least one pair, like you look at this kind of scenario, at least one pair is significantly different, right? And in the process of doing this thing right here, I know it's been a while, but you may recall eventually what we're doing is comparing a F-test statistic to an F cutoff, right? So let's say this right here is like our F cutoff. And by the way, especially on this exam that you just took, when it asks for, and a lot of you fail for, I don't want to say fail for the trick, it wasn't really a trick, but whenever it asks you for an F cutoff, you have to use the table for that. Like for example, in this case, you have to use the F table. Now, in the printout, for example, you may have seen an F value right there in the printout, but in the printout, the F value that you see is the F test statistic, not the F cutoff. All right. So long story short, in this particular problem, you may recall, you have to compare an F test statistic to an F cutoff. Now, the thing you'll probably be asked for, definitely. Now, first of all, do you know what 8 sub 0 should look like and what 8 sub 1 should look like? But the basic focus here is compare F test to F cutoff. Now, I think quiz 1, if I'm not mistaken, made you have to find the F test statistic. You remember how to do that? You remember how to find the F test statistic? It's something like this. This is something I can ask you on the final, or part of it. In order to find the F test statistic, it equals N times S sub X squared, S sub X bar squared over S squared pooled. In fact, if you have your notes, just kind of flip back to the beginning of the semester, and you'll see, if I give you a set of data, you're going to have to know how to calculate this particular value or parts of this particular value, all right? So let's say if group 1, group 2, group 3, I have to give you what N is. I have to give you what X bar is. So let's say 30, 35, 37. Then I have to give you what S squared is. 15, 7.5, 16. I don't know. So given this information here, are you able to calculate these values right here? Right? And so this goes way back. Talk about throwback. This goes way back. So force yourself to go through this exercise again. For example, S squared pooled is simply the average of this S squared, that S squared, and that S squared, period. Okay? So the hardest part of this problem is finding this thing right here. Is the variance across groups, right? So I'm not going to go over it right now, but just to sort of give you a hint about what I could be asked for, what I could ask you for. I may not necessarily ask you for F test statistic. I could ask you for a portion of these, like what is N? 5, right? What is S squared pooled, right? So I may not necessarily ask you about the whole thing, but just make sure you get the different parts. Also, the good thing about the final is that I have to be reasonable, okay? So even though I'm going over all of this stuff, clearly I can't ask you about everything, because when you're dealing with the final is cumulative, right? So it assumes that you have like a basic knowledge about all of the topics. Versus exam 1, you can focus more in on a lot of more things. Exam 2, focus on a lot of more things. But when you have to look at all of that stuff over time, over the course of the semester, to be fair, I just really can't ask everything. Okay, so just make sure you know a lot about a little, a lot about a little, if you want to think about it like that, or a little about a lot, right? Now, if you end up rejecting 8 sub 0, let's say reject 8 sub 0, if this ends up being the case, if your F test statistic ends up in the rejection region, then what I can do is figure out which pairs are significantly different using something called the Tukey range test. All right? And this technique, RANGE, and what this technique does is help you figure out which of the pairs is significantly different. M1 and M2, M2 or M3, M1 or M3, yeah, Lily. Yeah. I can't hear you, Lily. Are you talking?
Does that say reject H sub O right there, or H sub 0, sorry?
Oh, yeah.
Just because it's
Yeah,
blurry,
yeah.
I want to make sure I don't miss anything. Okay, thank you.
Okay. Is everything? Can you guys see? Is it blurry? I may have to try to do loan if it's not clear. It may be the marker. Can you guys see? Okay. If okay, I'll continue. If you can't, just keep letting me know. And I may have to try to do it from another site. Yeah. But this says reject x of 0. In other words, if you ended up rejecting x of 0, then you have to go to the next step, which is called the Tukey range test. And that's when you have to end up at some point using the Q table to help you there. And so generally what will happen is, I think on exam 1, I gave you something like this, where I gave you the printout of like the Tukey range test, and I asked you certain information on it. And one piece of the information that you're going to need for it is the Q table. Okay, so I'm not going to go into detail about that. Make sure you look at a previous lecture on how to choose that particular Q value. All right, you have to go over this amount, down this amount, but just force yourself to learn how to use the Q table over again. Okay, all right. Then we went to two-way ANOVA. To try to be a little bit clearer. Two-way ANOVA. Okay, here, this is when we have two factors trying to give you information on like what you're comparing, right? And this kind of involved this notion of interaction. There is interaction between the two factors. In x of 1, there is no interaction. Okay? And thank goodness here we didn't have to necessarily do any math per se, but you have to make sure that if I give you printout results of this thing, can you figure out how to interpret the results? All right? So depending on whether you accept or reject here, that will tell you need to go to the next step or the next level. If when you get to this particular point, you find out that there is no interaction, if you find out there is interaction, then you're going to have to go on to the next step to try to figure out, okay, well then what factor does have an effect on the results, okay? So again, it's too much to sort of go over here now, but I promise you, if you understand the problem on exam 1, you will be in good shape for the final, okay? And again, it's just a matter of going through to say, oh, okay, so I go here to check for interaction. Okay, it's depending on those results, I keep going to the next step or I stop, okay? Check your notes. I think I wrote this correct. I don't want to give any bad information. It's either there is interaction up here for x of 0, and there is interaction down here. Can somebody check their notes right quick to see if I wrote this one correct? This is going way, way back, like September. I think for two-way ANOVA, x of 0 says there is interaction, or does it say there is no interaction? Can somebody check that for me? It's either there is interaction or there is no interaction, and then down here is the opposite one. I forget. But anyway, if you find it, just let me know. But definitely go back to that lecture that we talked about and watch that one over again. Don't hold me to this particular part right here. It could be there is no, and then there is interaction right here. And then of course, yeah.
HO is there is no interaction, and H there is interaction.
Thank you so much. I know it wasn't really looking right. So yeah, so there is no interaction here, and then there is interaction here. Basically, you end up doing the same thing. You have this F cutoff, and you're going to figure out what the F test statistic is. But all the information, or at least most of it, is going to be on the actual printout itself. Okay, so you're going to have to look at the printout and sort of look at how the printout sort of is going to steer you in the direction of how to reach the conclusions regarding that. Okay, but there was no math that we necessarily had to do here. It was just interpreting the results. And I think in this particular case, when you look at the results, I think it gives you both the F test statistic and the F cutoff. I don't know. I can't remember. I can't remember. Just again, if you understand the exam one problem that has this on there, I think the problem was something like I think it had Dillard, Savola, and then like grade categories or something like that. I forget, but just go back and look at exam one and make sure you understand that particular problem and how to get answers to that. All right. The next topic we dealt with, so we only dealt with really 3 topics in this course. The next topic, we're going to say simple linear regression. Simple linear regression. All right. This is a situation where you have, what's called bivariate data, where you have data, you have 2 pieces of data for that one subject, or 2 pieces of data for something like store 1, store 2, store 3, and then you want to look at maybe sales and then visits. Oh, I don't know. So let's say $100, and let's say 35 people came into one store. $250, let's say 40 people came. All right. So you're looking at perhaps one of these is X and one of these is Y. Maybe the number of visits impact sales, vice versa, right? And you end up with this thing called a scatter plot. You guys remember that? Where it just ends up being dot, 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 something like that. Now, and you try to figure out what's the best line that sort of summarizes that data. All right. And here, what I could probably ask you for is the slope, which is M. Now, when I give you this problem, I'm going to have to tell you which column is X and which column is Y. Now, way down the line, when we got the time series, we did a little alteration of this. But in terms of, let's say, if visits is X and sales is Y, 9 times out of 10, I'm probably just going to tell you which one is which, right? You have the explanatory variable and the response variable. Explanatory variable pretty much tells you about the Y or response variable. But suppose I ask you for the slope, right, which is M. Would you be able to find the slope if I gave you some data? 1, 2, 3 pieces of data here, 1, 2, 3 pieces of data here. So in your notes, you remember the formula for slope? I don't. I know it's something like summation of X, summation of X, I don't know, I forget. But it had all those summation things, summation of this, summation of that. Make sure you know how to find that. And then it was like over something, I forget exactly. And then the y-intercept, so we have something like y equals mx plus b. And then the y-intercept was also something like this, summation of y, I don't know. But just make sure you go back over and make sure you have these formulas handy. By the way, I generally encourage students to, you remember we talked about the cheat sheet? And you had one cheat sheet for exam 1, another cheat sheet for exam 2. And I generally encourage students to use a cheat sheet. So 2 cheat sheets. If this was a face-to-face class, I would require you to come in with 2 cheat sheets, front and back, okay? Because it's just really something to have to do all this flipping pages and flipping, okay, so where's this in the chapter? If you can force yourself to get all that stuff on a cheat sheet, then I think it would be a better management of time. Was that Lydia?
Okay.
Oh, okay, all right. So yeah, so in other words, when you do your cheat sheet, in my opinion, I think that really helps you study, right? So that you aren't just, when I give you the exam, like just fishing for stuff. saying, I know it's here somewhere, and you're going through the whole book, and the next thing you know, 10 minutes has passed by. If possible, try to get this stuff in order. If you know you struggle with two-way ANOVA, then just sort of give yourself hints on your cheat sheet about sort of how to navigate that particular problem. But just find these formulas somewhere. And I can't remember if you guys had a quiz where you had to do something like this, but force yourself to go through and know how to, find that. Or, and I almost hate to say this, or if you think you know how to do it on Excel, right, and you know what you're doing, right, then maybe you can just put in Excel and that may give you the slope. I don't know. Okay, but if I say what is the slope, I'm kind of assuming you would do this by hand, right? You go through each part by hand. But if you're really, really good in Excel, then you can bypass all that stuff and just sort of make Excel do it for you. Okay, so that's a motivation to become more adept at Excel. Okay, so let's see, slope. Now, if you're asked to predict in this situation, and I think some of you may have confused predicting here with predicting with time series, which you want to get to eventually. But if I ask you to predict here, let's say predict, and let's say your equation looks something like mx plus b, right? And let's say it ends up being something like this, 0.5x plus 17. Let's just say it comes out to be something like that. And I say, let's say if X was website visits. I say predict sales when the website visits are blankety, blankety, blank. All right. Well, the first thing I need to do, let's say the website visits were something like 35, I forgot what I had, 17. I say predict website visits. I'm sorry, predict sales when the website visits were something like 26. Then I can just put 26 inside of X and figure out what Y is. But notice how I need to check to make sure 26 is in this range here, right? Okay, so if I say predict sales when it's 8 visits, then it does not make sense to give me an answer right here because 8 is not in the range. Okay, so that's just predicting. But now if I ask you to interpret, let's go back here. If I ask you to interpret the slope and interpret the y-intercept, let's talk about that for a minute. Let's talk about that for a minute. Interpret the slope. Interpret the slope, which is m. All right. So let's say if our m was something like, oh, I don't know. Let's say it's 2. Let's say m is 2. And remember, in this particular scenario, let's say sales was y, and like visits to the store was my x, right? And you ended up with something like YL equals 2x plus 5 or something like this. Okay, so I know that my m is 2. And I think a lot of us struggle with this because remember, we can interpret the slope here, but then when we get to multiple linear regression, we have to learn how to interpret that particular slope. And then when we get to time series, we got to learn how to interpret that particular slope. So I think most of us were maybe getting confused, at least on this part, I don't know. Well, if this is 2, this is the same thing as 2 over 1. And it may be that when some of you are trying to interpret, like if you don't see this 1 in the explanation, then maybe you think that it can't be interpreted, right? Well, if I say, okay, so let's try to figure this out. Delta, so m is delta y over delta x. So like delta y over delta x. So let's try to figure this out. X is visits, y is sales. So this looks like for every 1 visit, or you can just say for every visit. There's nothing magic about that number 1, right? For every visit, sales are expected to increase by $2 or whatever, right? But essentially, in this most basic case, what I'm doing is interpreting 2/1 as it relates to what's going on with the y over what's going on with the x right here. Okay, so for every one visit, that means x, sales are expected to increase by 2. So you're talking about something with the x and the y. All right. Now, if you have to interpret the y-intercept, we kind of mentioned this last time. If you have to interpret the, let's say interpret B, which is the y-intercept, what you have to do is make sure that the x's are included in the range. I don't know if that makes sense. So something like y sub l, let's say 2x plus 5. All right, because see, in order to interpret the b right here, or the y-intercept, so technically this is really 0, b, 0, b. I have to make sure that the 0 is in the range of the x values. So I forget the data that I gave you before. I think it was like sales, and I think I said like $100, $250, blah, 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 blah. If the 0 is not in this range right here, right? So this was sales, I'm sorry, visits. We go here. Because this was X and this was Y here. So this was something like 30 or 17. So in order for me to interpret the Y-intercept, I need to look at the X column and make sure the 0 is in this range right here. Then if it is, then I can offer an explanation for this here, which is 5, 0, 5. I don't know if that's too confusing. I'm not really being as explicit right now, but I think you had a quiz where you may have to interpret the y-intercept here. But the basic notion is just make sure that 0 is in the range of those x values. Okay. Then we talked about correlation. You guys remember correlation? Correlation, which is R. And this gives a sense of, like, if I give you a scatter plot, something like this, right? Or if I give you one that looks like this. Yes.
For the thing that we just did, so wouldn't there have to be like a negative number in the x for 0 to be in the range?
Good point. Not necessarily, because if the actual value of 0 is there, then that also counts.
Oh, okay.
Yeah. So if one of these is just 0, if nobody came to your store, then that's fair game. So yeah, I say at range, but it essentially 0 it has to either go to the negative area or 0 itself can actually be included. Now this correlation, can you guys look at this right here? I'm just making this up. Can you tell me what R probably is in this particular case here, if you had to guess? Remember what R is? It gives you a sense of like how those lines go. What'd you say?
Wouldn't it be 1 if it was perfect like that?
Yeah, pretty much, yeah. So if you have a line that's right on those points there, then my R is 1. What does R equals -1 look like? If you would have to look at the picture for that, what does R equals -1? Well, what would the dots have to look like?
The dots would start at the top and then go down as they go right. Yeah, like
Very
that.
good. Very good. Very good. All right. So my range, so here's R equals -1, and then you have the stuff in between, right? So R is either, the lowest it can be is -1, and the highest it can be is +1. But remember, if R is -1, that's not saying that's a bad thing. That's just saying it's a strong correlation just going in the negative direction. All right. So just make sure you know what the range is. Like if you say R is -2, then that just doesn't make sense. It can only be between -1 and 1. That's the ranges it can go. Let's see, the coefficient. And I think this is a problem on exam 2. I think I just asked you in general. So in general, if I give you a printout, which one of those values tells you whether your line is good at predicting or not? You know, if your line is really good at predicting, and that's the notion of R squared. R squared is called the coefficient of determination. Okay, and it's normally given as a decimal, something like 0.85, right? But you normally think about it as 85%. Okay, so this value here is related to R, but you just square the value of R and you get R squared. And this value right here pretty much tells you how good your line is at predicting. So R equals 1 here. So as if you square that, that's 1, and then that's percentage, that's 100%. So notice how the closer the dots are on this line here, the more reliable the regression equation is at predicting. Okay, so R squared tells you pretty much how good your line is in predicting. Okay, then we went to multiple linear regression. And as you see, I'm just giving a broad brush stroke just to kind of dust the cobwebs off of your mind. Right before we got to multiple linear regression, we took exam 1. So everything up to here was leading up to exam 1. All right, then we start talking about exam 2 stuff. Multiple linear regression. Okay, and this is when we start saying, well, there may be more than one X variable that we're using to predict our B, or predict our Y, I'm sorry. So as opposed to Y equals mx plus B, now we start saying, here's the first X, here's the second X, here's the third X, and then that's the Y-intercept there, all right? And pretty much, you're gonna have to know how to interpret results from this. Like I will never ask you to find the slope here. I could ask you to find the slope in what we just did, okay? It's too much work to try to figure out what the slope is in these cases. You just put it in Excel and just kind of look at the printout, all right? So when we get here, I wonder if like on exam 2, like there was a problem I gave you, I think it was 4. I was asking about CO2 levels, if you want to look at the exam. CO2 levels, and I gave you X1, X2, X3, and X4. And I said, for example, predict CO2 levels if, then I said the first one was, and I don't know, essentially I gave you values for X1, X2, X3, and X4, right? But I didn't give them to you in order, right? And I think what some of you may have done on exam 2 was you just automatically thought that when I gave you these values here, you just put the first one there, the second one there, the third one there, and the fourth one there. But when I gave them to you, the first number may have been for X2, and the next number may have been for X1. So just make sure you're kind of reading what number goes with which one, so you can make sure you get the right answer. So, but you can take a look at the solutions for that and see what I meant by that one. Because I think on the exam, like 10 or 11 of the problems just came from one diagram or one set of printout. So you're gonna have to be okay with interpreting the printout. Okay, so the first thing you're gonna need to do, if I give you a printout, do you know how to write the regression equation? Okay? And so you get the printout, what do? You go straight down to coefficients. right? And the information that's right there will help you determine what the regression equation is, okay? And I think that was one of the problems on the exam. If I give you a question like this, it's really like I'm trying to give you points, because writing the regression equation is probably the easiest thing you can do when you're looking at a printout. Now, everything else may be a little bit more difficult, but writing the regression equation is just going on the coefficients and writing those things there. Now, let's talk about interpreting these slopes. Let's say, because I think a lot of us had problems with this on the exam. Interpreting, let's say, M1. Okay? So I'm going to make something up. I'm going to say y sub L equals 0.5x1 plus 0. Let's say 2x2 plus 5. Oh, I don't know. Let's say if x1 is visits. Let's say x2 is I don't know, hours open. And then let's say y is sales. Well, see, now we're in a situation where we don't just have x and a y. Now we have this other variable that we have to sort of consider. So when we're interpreting M1 here, for example, what I have to do is fix the effects of what I'm not being asked about. And then once I do that, then I can interpret what I am being asked about. So let's take a stab at it. So interpreting M1 just simply says, for a fixed number of hours open, comma. See, because what I'm doing is I want to interpret M1, and that is matched with X1. So what I want to do is fix the effects of this right here so I can give an interpretation of these two things together here, X1 else. So I have to fix the effect of what I'm not being asked about. If you have more than one of these X variables, then you have to fix the effects of all of them and then come back to what you're being asked about. So for a fixed number of hours open, for every one visit, or for every visit, I think some of us may be hung up on the number 1 right here. For every one visit, or for every visit, sales increase by 0.5. Because here's my M1 right here. Here's my M1, 0.5. You can say over 1. Okay? So what am I doing? I'm fixing the effects of what I'm not being asked about. I'm fixing the effects of what I'm not being asked about. Then I'm going to offer interpretation of what I am being asked about in terms of this and this right here. So that takes a little, it's not easy. It's not easy. But I think with it being multiple choice, I think that's going to help you sort of rule out the options that it just probably can't be. And again, what I'm going to do, I'm just going to keep going through. We're not going to take a break. We're just going to go through and review, and then we'll take a break after we do this and, sort of move forward. But I think this may be kind of hard for some of us to kind of grasp, but, just keep working at it. Now, interpreting, let's say interpreting the y-intercept. Interpreting y-intercept. Okay, so this is the situation where the y-intercept here is the 5. You see the 5 right here? So essentially is 0, 0, 5. 1 here, 1 here. This is the first variable, 0, 0, 5. In order for me to interpret this 0 has to be in the range, or at least one of the values has to be a 0. This one in the second column, the second X column has to be included, 0, and then I can interpret this 5 here. So let's imagine that it is. Let's imagine that 0 is included in the first one and 0 is included in the second one. Here's how it would go. Interpret this first 0. when there are, how would you say that? How would you interpret this first 0, given that x1 is this, x2 is this, and y is this? When there are what? Put 0 in, how do you interpret 0 in that visits column? When there are,
Like no customers,
there
or
you
when
go.
no customers have visited the store.
Okay, or I'm just gonna say when there are no visits, all right? And what? Now let's
The
interpret
store
this,
is open.
right? And no hours open. What's the deal? When there are no visits and no hours open, what? This 5 here. Sales are expected to be 5, or whatever that 5 represents, right? But notice when I'm interpreting the slope, when I get down here, I'm saying sales increase by 5. But when I get to interpreting the y-intercept, I'm basically saying sales are expected to be 5, whether it's $5 or whatever. Yeah.
So just to clarify, for this interpreting y-intercept, it's the same as simple linear regression where 0 has to be in the range.
Exactly.
Okay.
Exactly. It's just that here you just have more than one x column to consider, right? But when I'm interpreting it, I'm still saying 0 of the first one, 0 of the second one, and then I try to interpret that whatever the y-intercept is right here, this 5 here, right? But that's exactly right. That's exactly right. And I guess I can really see the confusion, especially because when we get to time series, there's going to be another kind of variation that we have to do when we're trying to interpret the slope. But I want everybody to sort of get the general idea. When you interpret in simple linear, you only have one of those zeros. Multiple linear regression, you have more than one of those zeros. And in time series, something else is going to happen. But yeah, you're exactly right. You're exactly right.
Does 0 have to be in both x's?
Yes, it does. If it's in one and not in the other one, then I cannot offer an interpretation for the y-intercept. It has to be in both. It has to be in both. Very good, very good. Oh, this is really what got some of us. All right, so now we want to move to testing the overall significance of the model, right? So going back to y sub L equals m1x1, m2x2, ... plus b, all right? This is what really got a lot of us on the exam, I think. Because here what we're doing now is comparing different models. And I think we spent 2 class periods on this, so we're definitely going to ask about this. But again, it's just a matter of interpreting the results. So if I want to test the overall significance of the model, what I'm doing is starting with here. Now these become capital M's, you know, equals, and I have to put this equals 0 here, because essentially what I'm doing is I'm going to be looking at to see which one of these models or which one of these independent variables is contributing significantly to my y, okay? Then normally I say H1, we'll say at least one of the m's is not equal to 0. Okay, so again, I don't have time to go through this entire lecture all over again, but I can just give you a general idea. Well, when I'm comparing across models, if my k's are different, when I'm saying k's, I'm looking at how many x variables I have here. Like in the exam, again, I think there were 4. There were 4 x's. Total pounds recycled, you know, you can look at that problem if you want. So that's 4 k, so my k is 4. And then the extra credit, a few of you did well on the extra credit, where I'm not only looking at the different scenarios where K was 2, but I also have to look at how many times you have 3 and how many times you have 4. So for K equals 2, I have x1, x2, do a regression on that. x1, x3, do a regression on that. Right, so you have those, then K equals 3, x1, x2, x3, x1, x2, x4, blah, 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 blah. But you can look at my solutions to the extra credit on that to sort of get more ideas about that. But for extra credit, you had to do like 11 different separate regressions, right? But none of them should have been when K was 1. See, when K is 1, that's simple regression. See, I only have to start at K equals 2, then K equals 3, then K equals 4, and then compare the adjusted R squared values. So in the quiz, when it was telling you, it asked you a question, what is the purpose of adjusted R squared? I think that was a question. And that's when you want to compare models when you have different values of Ks, Okay, well, anyway, when I go to this particular problem here, the first thing I do is check the significance of all of the X values all together. So in the problem in the exam, it said something like, test the significance of the model of the entire set of variables. So all 4 variables together. The only way I can do that is to start off with the F-test. And depending on the results of the F-test, that's going to tell me whether I'm going to go on to the next step, which is individual t-tests. It may be, depending on these results here, that I don't even have to go to these individual t-tests, right? So what I want to do is look at the F cutoff and compare the F-test statistic. Here's what I fear on the exam. Remember, if it asks you for an F cutoff, the only way I can get that F cutoff value is to go to a table. Now, if you look at the results on the exam too, when you look at the printout results, it gives you an F there. I think it was something like 39.33, right? And I think a lot of you chose this as your answer for the F cutoff. But this is the what? In the printout, when it gives you that F, this is the F what?
F-test.
That's the F-test. Very good. See, that's the F-test. And, you know, you can probably imagine if you have a, okay, yeah, good. Yeah, you can imagine if I give you a multiple choice exam or something like that, I'm going to have this as one of the solutions because I want to make sure you understand the difference between F-test and the F cutoff. Now, in this particular problem, I think on the exam, I think the F cutoff ended up being 4.43 or something like that, because I think my alpha was 0.01. You have to go across, in this case, 4, because you have 4 variables, and down, I think it was 20, whatever numbers beside residual, right? Which is n minus k minus 1 in that case. All right, so just be careful. Just be careful. A lot of times you don't want to fall for the okie doke and say, oh, okay, there it is right there. See, this is the F test, but the F cutoff comes from the table. So let's see, my F test I think ends up over here.
When you say go to the table, do you mean the T table for the F cutoff?
No, you gotta go to the F table.
Okay.
You gotta go to the F table. And then just make sure you're looking at the correct side, either 0.05 or 0.01. Yeah, I think you go over 4 and down 20. Now, looks like this ends up being in the rejection region. And if it's in the rejection region, that makes me go to the next step of T, 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 right? Depending on which one I'm asking for. So that's that. Now, assume you have to go to the next step. And in the exam, I think I made you have to go to the next step in a couple of the problems. Now, what do we do here? What do we do here? Look at your exam, if you have it. And let's say, oh, I don't know. I'm just going to make this up. Let's say if I ask you about the third one, which may be like total pounds recycled or something like that. And just make sure on the exam, I'll always tell you what X1 is, X2 is, X3 is. So let's say if I ask you about X3, right? And I say, well, does that one have a significant impact, right? So then that becomes, if I ask you about M3, so now whenever I ask you about an individual one, that individual one has its own H of 0 and H of 1. So there was one question I asked you about the alternative, and it should have looked something like this, either M2 not equal to 0 or M3, I don't know. But when you get down to the individual T's, each one of them has its own null and alternative. Now, once you get here, and you do the test, this becomes a T test, not an F test anymore. So you're going to have a cutoff right there, and you're going to have a cutoff right there. Now, again, if you're not alert, and if I ask you for the T cutoff, you're going to think that the T cutoff is the thing that's under T stat in the printout. That's not the case. That's the T test. I got to, again, use the chart. So you're going to have your T table. You're going to go to two-tailed, right? And depending on what the alpha level is, just make sure you go to the right alpha. Then go down. I think in this case, whatever number is beside residual, you go down to there, and then that will determine what the T cutoff is. Now, let's say the answer here, I don't know, I think an exam was something like 2.845. If that's a cutoff, what else is a cutoff? If 2.845 is a cutoff for the problem, what also is a cutoff?
Negative 2.845.
Yes, yes. See that? Negative 2.845, right? Because see, with the T, when you get to the T's, it's only going to give you that positive number, but you got to remember that because of symmetry, it's also going to be the negative version of that. Very good, very good, very good, very good. So now what I have to do, and this is like in the middle right here. So now what I have to do is now go to the number that says T stat for whichever one I'm looking for and see where it fits inside of this situation here. So now this is accept, and then these two on the end, those are reject, okay? If it falls in the rejection area, then I'm saying that it does have a significant relationship. If it falls in acceptance, I said it does not. Okay, so I don't expect you guys to memorize this. I mean, I only know it because I have to teach it, right? And when the semester's over, I'm going to forget it. Okay, so you know, just make sure you have at least a pattern of how things should go for that. All right, any questions on that? But yeah, I would really go back and look at those lectures again because I think we took 2 class periods to deal with this right here. All right, yeah, I see the time. I know you guys are tired. But just give me one more, just go to time series and then we'll call it a day. And any questions, any questions? See, this is not over your head. This is not over your head. And I don't know if it's test anxiety or whatever, I mean, but I really believe you guys know how to do this. I'm not gonna say you guys can't do this. It takes a little mental power and you know, you can't have your baby cousin beside you saying, feed me. You're gonna have to get somewhere aside from everybody else and you know, try to get through this stuff. All right. Yes. How
many questions is the final?
I don't know. I haven't done it yet. I would say probably between, maybe I would say no more than 30. No more than 30. But remember, each one of the questions is not something that you have to slave mathematically for, right? Some questions just may be short answer. A lot of them have to do with interpreting results, just like on exam 2, right? So I would say no more than 30, no more than 30. And it's probably not going to be an extra credit, and it's not going to be an Excel question. So if everything is literally, so I'm going to say between 30 and 35, 30 and 35. Time series. Now, let's see how this is different than what we talked about before. So you remember we had the situation where we end up with like a regression equation. Well, we're going to end up with one here eventually as well. So we'll see what the difference between that is. So time series, you have a time category here, January, February, March, and then you have the Y here, whatever the Y is. The time will always be the X there, and then whatever the Y is, sales or whatever. So let's say 150, 130, 200, whatever, I don't know. All right, so the time series, so you already see how it's different. You already see how it's different. Never before up to this point have we had where the X column could be words. Because see, even before in linear regression, we had X was like visits and then sales, but all those were like numbers, right? Now we could have numbers here, like years 1982, 1983, 1984, but those are numbers that are not to be calculated or included in the calculations, okay? So just make sure we know the 4 components: trend, cyclical, seasonal, irregular. Now on the exam, I asked you about, I think, probably irregular. I probably asked you about trend and irregular. And in the data that I gave you on the exam, the most irregular component, I think, was between 1960 and 1961. That value just really shot way up, right? So in comparison, that was the most irregular or random one. But just in general, time series is, just a successive or consecutive number of data, and you sort of join them, connect the dots. All right. Now we talked about a few smoothing algorithms we're going to have to be comfortable with. We talked about the SMA, WMA. Then I'll write the other one later. SMA, let's say if you have an SMA 3, then this first value here is going to be what? If I give you an SMA 3, this first value, let's say April, I'll add one more. This value here in SMA 3 column should be what? In general. Remember this? NA. Why is that NA? Because the window is size 3. 1, 2, 3. And so the first answer for this will always go in the middle of the window. Boom. So that means there's no answer right here, right? Now, if you have 1 at the top, you're going to end up having 1 at the bottom, one of those NAs there. If you have an SMA 5, you see how the window would be the first 5 points here, and then your first answer will be in the middle of that window, which would be the 3rd time slot. So you have 2 of them here and 2 of them here. So it depends on what your size window is. Now, how do I calculate this box right here? So you don't have to tell me the answer, but if I gave you this on an exam, how would you calculate that answer?
You would add up the first 3 values, so 150, 130, and 200, and then divide them by 3.
Very good, very good. And that would be that answer right here. All right. What if I for this answer right here? What would you have to do?
You would move down 1, so you would do 130 plus 200 plus 250 and divide it by 3.
Good. See, the window size is the same, but now I'm moving to those numbers right there, and that'll correspond to that answer right there. Very good. Let's go here. This behaves the same way as the SMA3 in terms of NA here, NA here. Now, if I want to calculate this answer right here, I'm still going back up to, see, the window is still size 3. I'm still going to go back up to these 3 points, but I'm not going to get the average of these points. I have to use certain fractions that I give you, right? So I'll say 1/2 for most recent. Then I'll say something like 1/3 for second most recent, and then 1/6 for the oldest. I'm just making this up here. All right. So in this case, this 1/2 would go with which one of these numbers here? 1/2 times what? In this particular case, the most recent. Out of these 3 numbers, which one is the most recent?
200.
200. See? So January, February, March, this is the one that's closer to me. So we'll have 1/2 times 200, then plus 1/3 times 130, and then 1/6 times 150. See that? See that? See that? See, whereas the SMA, we just did the average of those. We go over here, I have to give you the fractions. I have to give you the fractions, and we're going to use most recent, second most recent, and then that one there. Any questions on that? Any questions? Very robotic. Yeah.
250 be the most recent?
250 would be the most recent in general, but I can only choose which one is the most recent in terms of the window that I'm in. So you see how this is WMA3? And so out of the 3 numbers in the window, then 200 would have to be the most recent. In other words, I haven't gotten to 250 yet. I can only answer that question because you see how this value right here is only based on these 3 numbers. So out of these 3 numbers, March is the most recent. I'm going to go here. Then the window moves down, and now it includes the 250. So for this answer right here, now the most recent will be 250, and then 200, and then 130. You see that? See that? So when I'm saying the most recent, I'm only answering the question based on the current window that I'm dealing with there. All right, almost finally. Let's go to EWMA. According to what you see, what value goes right here? Is it NA? What is the first value that goes right here? For any EWMA problem, the first answer, and let's say this is
It's the 150, isn't it?
Yeah. Yeah. See this answer right here? We do EWMA is always going to equal to this first number right here. Very good. Very good. Now I have to give you what lambda is in the problem. So if I'm smoothing, everybody write down the equation that would give me that answer. You don't have to solve it. Just write down the equation that you would use to get that answer. Everybody write that down. Don't solve it, just write down the equation. Write down the equation. Ashley M, any idea? What equation would give you that answer right there?
Hold on, I'm still looking.
Okay, all right. Yeah, there has to be an equation. Like, remember, here's my lambda right here, 0.4. How do I get?
That was me, Professor Kiara. Is that the lambda YT plus 1 minus lambda EWMA? Is that one?
Yeah, very good. Well, good. So now tell me the actual numbers that go in that equation. So equals what? So in other words, what is lambda here?
0.4.
Okay, so 0.4 times
130.
130 plus
0.6.
0.6 times
150.
Very good. Now, which 150 are you using? The left one or the right one?
The 150 above the value you're looking for.
Very good. See, this answer right here comes from this and the answer right above it. See that? See that? Very good. So it's my 0.4 times this plus 1 minus lambda, or 1 minus 0.4, which is 0.6, and then times this one right here. Very good, very good, very good. So very algorithmic, very robotic, very, you know. Now let me ask this right quick. Suppose you get down here and you say, you find out this answer is 270. And that if I tell you to predict y for April, for May. So I'm asking you to predict this, predict y for May using EWMA. Can anybody tell me how we do that? So we have smoothing, and then we have predicting one time period outside of the given data. Because see, in this problem, the data stops at April, but I want to predict for May. Anybody remember how to do that? How do you predict one time period outside, one time point outside of where you're given using EWMA? Well, virtually it's the same thing. When I'm smoothing, I'm using this beside it and the value above it. But when I'm predicting, I'm just going to use both values right above it. So this becomes 0.4, which is lambda, times 250 plus 0.6, which is 1 minus lambda, times 270. Notice how when I'm predicting, both of the numbers come from the time period right before it. Whereas up here, one comes from the same level and one comes from above it there. All right? That's good. And then finally, for the entire course, what's the last thing I can ask you for given something like this? I can say predict y for May using EWMA, or I can say what? Or I can say predict y for May, predict y for May using what? Regression. And so now this is where things can get a little bit confusing because we've already seen regression before, right? But now this was part 2 of the exam. I gave you a problem that kind of resembled this. I don't know what some of y'all did, but if I give you this time series and I say, for example, predict using regression, well, the first thing I got to do is change this column to an alias column. Alias column. And I got to do something like this becomes 0, 1, 2, 3. And now I do regression on this. This becomes my X, this becomes my Y, boom. Put the information in Excel and then kind of look at the printout, right? So essentially what I have to do is change to alias column. In other words, change your X column to alias. And when I say alias, that makes it 0, 1, 2, 3. And then just do a regression with this is my Y and this is my X. All right. Now on the exam, I'll just probably give you the printout. And I'll say something like, you know, when you want to predict. So you have something like y equals mx plus b again, right? Go down to coefficients. When I say predict, you're going to end up with something like y sub l equals, let me make this up, 0.6x plus 20. Let's say you end up with something like this. Now notice, all this looks like regression still, but the number that I'm going to put inside of here is probably going to correspond to the number that says observations. Like if you have 14 of these right here, then you have to put in the number 15, right? I think it's going to be the number beside observations that you put inside of here. So something like 0.6 times, let's say 15, for example, whatever the observation is, and plus 20. And then that becomes your prediction. That becomes your prediction. You get the regression equation based on what Excel gives you, and then you put in the number, I think, beside observations, which represents one more than the data that you kind of have. Now, the very final thing is how to interpret the slope and the y-intercept in this situation. You see how we've seen it already in simple, multiple. Now let's interpret it here, and then we'll call it a day. Let's say interpret slope, and then interpret y-intercept. Okay, so let's say if my slope is 0.6. All right, and let's say if on the exam, I'm trying to remember what I gave on the exam, but anyway, okay, so let's say if x was, I guess there had to be time. Let's say month, like January, February, March, April, whatever. And then let's say y was sales. So in this case here, for time series, the x is always going to correspond to the time, whether it's January, February, March, or 1982, 83, 84. So here what I have to say is something like, so this is still over 1. I'm going to say for every 1 month, that's assuming that the data is monthly. I can say every month, for every 1 month, right, sales are expected to increase by 0.6. I don't know. But notice here, the difference in general is this first part of the sentence has to deal with that notion of time. See, for every 1 month, or for every 1 year, or for every 1 day, monthly, daily, or whatever here, then I go into this thing here. Now, interpret the y-intercept. Interpret the y-intercept. Well, the y-intercept is still b. It's still 0, comma b. But interpreting the y-intercept here, this 0 here, see, ordinarily we said something like when there are no visits or when there is no such and such. But see here, this 0 corresponds to, you remember when we looked at the data, I had year or like month. I had something like January, February, you know, and then I changed it to an alias column. When I change it to alias column, you remember how this is always 0 right here? See, 0, 1, 2. See, this 0 in this interpretation corresponds to this month or this first data point, right? So I have to say something like, in this case, for the month of January, comma, see, because see, this 0 in time series corresponds to this alias, which is this first data point, or if it's Monday, or if it's 1982, right? I just have to put that as the first part. For the month of January or whatever, sales are expected to be, well, I didn't write it. I'm going back to here, 20. And I just made this data up, but assuming that this is what my regression equation is, my y-intercept is 20. So when I interpret the 0 right here, I'm going for the gusto in terms of what that z represents in terms of the data, in terms of the time period, and sales are expected to be 20. So we have a lot going on because we've seen kind of regression in different aspects. So just make sure we kind of know how to parse through and give the proper interpretation for that particular kind of problem. I know I just squeezed the whole course into an hour and a half, if not that, but again, please don't come to the final without redoing all 4 quizzes, exam 1 and exam 2. I promise you, if you get through those, if you understand those, you'll be in a very good position for the final. Very, very good position. Very good position. I am going to have office hours Monday and Wednesday of next week. So if you think you want to, I know I have somebody already coming Monday. So if you want to join us Monday, you're more than happy to do that, because I'm not going to see you guys until next Thursday in terms of giving the final. So let's deal with any questions, any lingering questions we have for the entire semester. What other questions? Let's deal with any questions you may have. You know, I tried to do the best I could do. All of us are trying to wing this COVID stuff, and it's not the ideal situation, but you know, life is not fair, you know, in terms of I'm teaching from my bedroom, right? But I think you guys really hung in there. I think you should hold your head up, and I think you should go down fighting. Go down fighting. It's not over until it's over. And I know you have other classes and all that stuff, but you've got to find it in yourself to fight one more time and give yourself the best chance that you can in passing. Again, it's not over if you failed exam 1 and exam 2. I was telling another student in another course, I actually had a student, and he was real distraught. He failed exam 1, he failed exam 2. Now, after that, he came to my office every day to learn what he kind of missed, but he ended up getting a B on the final, right? So this is doable. And I don't want you to sort of write it off and say, oh, well, I just failed. You've got to give it a whole, you got to give it another shot. You got to give it another shot, okay? So again, I don't necessarily like talking to blank squares either. You know, put yourself in my position. I have to act like I can see you, right? So I'm normally in the class, I can sort of walk around, sort of give you hints and all this kind of stuff, but you know, we just have to work with what's working and give it one more good push, one more good effort. I did receive an email from the registrar, and I think I kind of mentioned this before, where if this is not a major class, or if this is not a capstone class, then I think you're able to change this grade to an S, right? If you just don't want it to negatively impact your GPA. But the only way you can do that is get an A, B, C, or D in this course. It doesn't work for Fs. So if it's any consolation, everybody should shoot at least for a D. I mean, I know it's not the best prep talk, but you know, if you can tell yourself, if I can at least squeeze a D out of here, then, but you got to earn it. You got to earn the D. You got to earn the D, right? So then what I'll do is that I'll send you the email that they sent me in terms of once the grades come out, you can sort of be in contact with the registrar. I'm going to send you also an email to let you know the Google Meet link. And then I'm also going to send a separate email concerning when you'll be able to see your grades and all this stuff. The short version is I'm not going to tell you what your grade is in the course over email. You just got to log into like my FIT or whatever. And I'll let you know what day you can email me to find out how you did on the final exam itself. But I'm not going to tell you over email, yay, you passed, or yay, or you failed. You just have to wait till those grades come out. Any other questions? Any questions? Any questions? Yes.
I feel like this is arguably the easiest part of everything we've learned, but for some reason I'm not understanding the like time series trends, like the cyclical, abnormal, flatline, all those ones. Can you just go over them really quick?
Yeah, real quick. Well, okay, so let me do this. What I'll do is I'll go ahead and if you guys feel comfortable with where you are now, what you can do is actually leave, because we're kind of finished the official kind of review. And then if you have questions, just like the one posed, just kind of hang back and we can sort of go over any topic that we kind of need to clarify. So I just don't want everybody to just kind of just sort of hang out and wait. Now, if you want to hear this explanation, that's fine. But if you guys feel comfortable with that, it's definitely been my pleasure to work with you guys this semester, and I wish you all the best. I'll see you on next Thursday morning. But if you want to stay, you're more than welcome to stay. And other than that, have a good rest of the day. So just give me 1 second, and then I'll go over that. All right. I'm just going to let everybody who wants to leave kind of leave. And so if everybody else, you're more than welcome to stay, and sort of if you need clarification on anything, we can sort of go over some more stuff. All righty. As a matter of fact, can we take who asked me about that? Was that Lydia? Who asked me about that?
Yeah, that was me.
Okay. Can you do me a favor? Can we just take a 5-minute break? My throat is kind of parched.
Yeah, absolutely, no problem.
Okay. So if you guys are still in here, just let's take 5 minutes. Let's come back at like 10. Let's say 10:55. I just need to grab some water and do whatever. But if you're still here, if you have questions on like a previous quiz or part of the exam you want to sort of go over, then just find that and we can sort of continue today. But just give me 5 minutes. Just give me 5 minutes. Okay, all right. So let's see. Let's talk about this time series again. So so in terms of components, so the first one we have, of course, is trend, and that's dealing more with just a basic upward like down pattern. So something like this, clearly that has an upward trend, right? And then the downward sort of going the other way, right? So you either have upward, downward, or you have one where you can't really make it out. The dots, are more sort of like centered, and you can't kind of scope in to see exactly what the trend is. Now, cyclical, we'll sort of leave that there. Now, cyclical is just getting at what do you see as being a repeat kind of pattern. So let's say, and I would have to sort of know like how the data is presented. So for example, if we have something like January, February, March, April, and to let the cat out of the bag, I mean generally, if I give a problem sort of like this, I guess how the information is given out here is probably going to be the answer. So because when you're doing a time series, at least in this course, it has to be kind of obvious what the kind of repeat kind of pattern is. In real life, there may or may not necessarily be one of these kind of patterns. But let's say, for example, it looks something like this. Let's say something like here, then let's say it goes all the way up down here, right? So do you see, at least you may not necessarily can see this, but do you see how every month is doing basically the same thing? How it's sort of going up, boom. And even though this went sharply up, it's still giving you that same pattern. You see how it's kind of like up then down here, up then down here, up then down here. So it doesn't say it doesn't have to be necessarily a mirror image. The mirror image is pretty much, it looks exactly the same, right? And even if it increased, even if it sort of had like an upward trend, even if it kept doing something like this, I'm just looking at the fact of what is the repeat kind of pattern, and it looks like the repeat pattern ends up being monthly, every month. So I would say the cycle here would be monthly or every month, right? But it's just trying to find out where does it seem like it's repeating. So on the exam, I think these down here were, I think it was years. I think on the exam it was years. So then you notice that, I think it was airline passengers or something, and notice how it gave you the same kind of movement in terms of cycle every year. Even though this block here between these years here was maybe elevated, like maybe up here, right? The actual repeating pattern was yearly on the exam, and then it's monthly here. Now, if I want to say something about seasonal, now, the first thing I need to do before I say something about seasonal, I need to say something about the cycle, because I can only talk about seasonal after I have identified what the cycle is. So you see how this cycle is monthly, there's a repeat pattern. Once I identify what the cycle is, now what I need to do is take a magnifying glass and get rid of like all the other cycles and just focus on one of the cycles itself. Either this one, or this one. Let's say I want to focus on this one. Now, but when I start talking about seasonal, that's when I say something about what's going on between January and February. See here? So I could say something like, it seems like, so seasonal would say something like more, let's say if this is about airline passengers or whatever, more airline passengers tend to fly in the beginning of the month. Right? Now, I just kind of made this up, but in terms of, I don't know if you can see that. But notice here, what I'm doing is once I identify the cycle, then I can start talking about details about what goes on inside of the cycle. You see how this little peak right here seems like that's the highest point within that cycle. So that's why I'm saying if this is about ridership, airline passenger ridership, I'll say, you see how this value right here is kind of close toward the beginning of January? And it kind of happens to be the same way. And that's why when I gave the data, I kind of make sure this spike was kind of in the beginning part. So I'm saying the top or that most of the passengers tend to fly at the beginning of the month. See, that's true for January, February, March, roughly April. But here's the point. The point is when I start talking about seasonal, I start talking about maybe the high value that's within the cycle. See that? See how this is sort of like the high value in the cycle? And you're just guesstimating, like you don't know what date that is. Is that January 8th, January 9th? I don't know, right? But just in general, I'm saying I want to go to the high point and say something about that high point in the context of the problem. Does that make a little bit of sense?
Yeah.
Is that kind of okay? And one thing you can rest assured is that if I give you a problem like this, I'm always going to choose a data set where it's going to kind of be obvious, right? Kind of what's going on there. And then of course, irregular. Number 4 is irregular or random, right? And that would just be the point that kind of stands out from the rest of the points. And if I had to guess, if I just look at this and guess, I would say that point right there is the most irregular. Just because when I look at the other points, that one just really tends to stand out more than any other point, right? So it's just really just like a visual, kind of easy visual kind of visual kind of observation, just kind of say, oh, that one just tend to be a little bit higher. Is that during the holiday time or is it whatever? But for whatever reason, that one spikes a lot, or maybe spring break, who knows, right? But clearly you wouldn't know the details about it, but you should be able to visually inspect and say, that one just doesn't seem like it goes with the rest of the points there. So that's a general kind of, that's all I'm going to expect you guys to kind of to know on that.
So for the exam, where you kind of have to look at the language, right? Because I know there was one that was asking what the trend was, but then that would only be upward or downward. The rest are components. So you have to be careful of the language.
Let's see. Did one of the questions on the exam ask you about trend?
Yeah, because I got that one wrong because I chose cyclical, but the right answer was upward. So I think.
Oh, right. Well, yeah. I think. I think I put some of those answers there just to be like a smoke screen.
Yeah.
But whenever I ask you about trend, it's only asking you for is it upward, downward, or none at all, right? So only upward or downward. Yes. So these here sort of carry their own kind of definitions there. I think I just put it there just to be like a smoke screen or something.
Got it. Okay. Thank you so much.
Okay. All right. Okay, everybody else that's still in here, let's see. I guess if you know what problem you kind of want to deal with, you can let me know. I don't know who's going to go first. It's not that many of us in here, so whoever's next can go next. But now is the time, not to try.
Oh, Professor, I had a question about the EWMA. Is that the one with the fractions?
Is that the one with what?
The one with the fractions where we put in the different fractions you give us?
Okay, so if I give you like the 1/2 and the 1/3 and the 1/6, Now that's for WMA.
Oh, WMA. Sorry, that's what.
And those will only be used for WMA, and like if I give you like a WMA3. But now, and all of these sound the same, right? And then if I give you something like EWMA, I would have to give you what lambda is.
Okay.
See? Yeah, so EWMA is where I give you like lambda is 0.4, but WMA is where I have to give you those three separate fractions, right? So I don't know if we do something like, I mean, do you want to go through and do one? Is there anyone you have in particular?
Yeah, could we do one? Because I feel like I don't know if I'm like putting in the I don't know what I'm doing, but I keep getting the wrong answers with them. So.
All right. Is there a problem that you see you want to do, or do you want me to make one up?
Could you make one up?
Okay. All right. So let's say year, and again, I'm going to go back to sales here. And let's say 1985, 1986, 1987, 1988. And let's say sales are $250, $300. I mean, I'm literally just making this up as I go. $400, $150. And if I give you something for you to fill, all right? Now, do you understand why we did this right here in the very beginning? In terms of, I mentioned that in the beginning. Is it clear why that's there? Faye.
I think isn't it because like you have to use like 3 of the years, and because it's just the first year, we don't have enough like information for that.
Well, kind of. Okay, so you see how this has WMA3 by it?
Mm-hmm.
So this 3 means that I'm going to look at the first 3 values in the data column. Now, when I say data column, I don't mean the years over here, or it could be January, February, March. So literally, I'm looking at the data in this column right here. So 1, 2, 3 corresponds to this 3 right here.
Okay.
Now what happens is, so say for example, I give you the 1/2, the 1/3, and the 1/6. Now, considering this window right here, once I get the answer, I'm always going to put the answer to this in the middle of the window, boom, over here. That's why I put this value right here, because the saying, when I consider the first window option, the middle of the window or the answer is going to correspond to the middle of the time point, which is right here. That's why nothing is going to go right here, and then nothing also is going to end up going right here. Okay? Now, when I do this, I have 1/2. Now, out of this window right here, so this is the first window of size 3. Out of this window right here, which one of the values corresponds to the most recent? So look at 1985, 1986, 1987. Which one of these dates is closer to where we are now in the world?
1987.
1987. So that's why I'm saying that this value of 400 corresponds to the most recent in terms of this window that I'm looking at. Now, you may say, well, no, 1988 is closer, but I'm only asking the question based on the current window that I'm looking at. See, this 150 is not a part of the window that I'm looking at initially. So when I'm assigning these 3 fractions, I can only look at this information right here to determine what's the most recent. Okay, so that's 1/2 times that, then 1/3. Now the second most recent is this date right here, which is 300. And then plus the 1/6. So this is the oldest in the window. Now, would you know how to put this in your calculator right here? Do you know how to find that? See if you can figure out what that answer is that you put in your calculator. And depending on what calculator you have, you should be able to put the fraction in, I guess. Like, can you do like one? How do you do? Let me see. Give me 1 second. Let me see. I'm going to try. Let's see. Let's try to do this. I'm going to say, see if you can do 1 and then divide it by 2. So literally just 1 divided by 2, and then say times 400.
Okay.
Plus. So I'm going to try to put it all in together.
Okay.
Plus, now do 1 divided by 3 times 300, and then plus 1 divided by 6 times 250 equals. And tell me what you get when you get that. Like, do you have a scientific calculator, or are you using your phone?
I've just been using my phone. I got 341.6.
Okay, yeah, good. Because see, I was a little worried about whether it was going to. I was worried if your phone was going to treat it like a scientific calculator. Because see, I have a scientific calculator, and it knows to sort of don't do any calculations until you put everything in there. And so yeah, I'm getting the same number, 341 like 0.67 or something like that.
Yeah, that's what I got.
Yeah. So then this would be the answer for that. Now, suppose I give you on the exam, suppose I give you the same information, then I have the letter B right here. Now, the thing with this is, let me write it this way, 341.67. 341.67. Now, you're going to find out that the same number of NAs that you have right here is going to be the same number in the very, very end. So it's going to be like a mirror image. You have 1 here, you're going to have 1 here. And I think as we go along, you'll see why that's the case. But if I give you a B right there, would you know how to calculate B? Remember, the fractions are 1/2, 1/3, 1/6. How would you calculate this B right here?
Would the range just move down? So
Right.
1/2 would go with 150.
Right.
1/3 with 400.
Yeah, because see, so in other words, it'll kind of slide down like this. And do you see how there is no more data down here? So that's why when you get this answer, it's going to go right here. And that's why we don't have any more data to consider. That's why this goes right here. See that? So this NA is saying there is no more data to consider, because once I get this answer right here, it's now going to be in the middle of this window, which is right here. See that visually?
Yeah, that makes sense.
All right. So go ahead and figure out what this answer should be right here. Remember, those are the fractions. See, the fractions don't change. The fractions don't change. The only thing that changes is the movement of the window. I'm going to do it too to see if I get the same thing. Let me know what you get when you get a second.
I got 258.3.
Very good. Yeah, that's what I got. Okay. But notice here, how you shift it down 1, and that's going to occur. And so whatever answer that you get for this, it has to go in the middle of the time period, which is right there. So then what happens, and I don't know if I did this on the exam. So let's just say you start off with something like this. And let's say I have something like missing, and then I have something like A right here. And I gave you these 3 fractions. So first of all, let's say you're in the WMA column. So this assumes that you know in order to solve this problem, I have to give you 3 fractions, right? So in the problem itself, I may give you the table, and I say, what is the value of A? So I'm not going to tell you that this is the technique to use when you have 3 fractions. You just got to know that, okay? Just like EWMA, and we're going to get to that in a second. But suppose I just give you a table that looks kind of like this, and I say, find the value of A. Do you see how in this problem, it makes you, first of all, have to know that you have to use these 3 fractions at some given point. And you have to know that, first of all, it's a WMA 3. So the window size is going to be 3. But then the question becomes, in order to get A, what 3 values am I going to use? So how would you know in this problem which 3 of these values to use along with the fractions? Like how would you know? What 3 values go with A?
For A, it would be 150, 400, and 300.
Okay, how do you know that?
Because even though the one above it's missing, the range for that would be the first 3, and then you just go down 1.
Exactly. Because visually, that when I ask that question, it makes you have to answer certain things in your mind, right? So this A right here, if I know that this answer here corresponds to the middle of the window, then by default, I know that the middle is right here. So it has to be this point, the bottom point, and that point right there. You see that? You see that? Because see, this A, I know the window is size 3, and then I know that whatever the answer is, it has to be in the middle of the window. So the middle is here, so 1 here, 1 here. So those are the 3 points that I know go with this A right here. Now I still got to use the fractions, right? 1/2 times this, 1/3 times this, and 1/6 times that. But at least I know that the values are not the first 3. See, the first 3 go with this one right here. You see that?
Yeah.
Okay. Let's go to EWMA. Let's go to EWMA. Now, when I get to EWMA, these fractions are no longer necessary. See, these fractions only go with this right here. By the time I get to EWMA, this becomes my fraction, the 0.4, right? Now, let's say I have something like this. 250, let's say missing, well, no, let's do this. Let's just say, wait a minute, give me 1 second. Okay, so let's say this is this, and let's say B, I'm gonna leave that B right here. Now, suppose I give you something like this, where the question says, find B, find the answer for B. How would you go about finding that? So this A is in this column. How would you go about finding B in this scenario? Now remember, when I'm thinking about EWMA, this no longer matters, right? This right here is only dealing with sales. So the EWMA column has nothing to do with the WMA column. So how do we calculate an EWMA column, the values for that column?
Would it just be 400 times 0.4 plus 150 times 0.6?
Almost. That's good. Because now remember, when I'm going to find B, remember how we said that this B corresponds, okay, so that's right, 400. And then it also corresponds to what's right above it.
Oh, okay.
Remember that? Right?
Yeah.
So the EWMA is looking at the Y of the same level and the EWMA of the level right before. So we're going to have 0.4 times what?
Times 300?
Well, let's see, what's the 400?
Oh, 400.
Yeah, 400. Because it's going to be the one that's on the same level, All right, and then plus what?
0.6 plus 300.
Well, times
300, sorry.
Not 300, but what? See, we got this level here, and then what? Right above it.
The 270?
270.
Oh.
Because see, WMA, which is the column that I just erased, those answers all come from like these three or whatever. But when I get to EWMA, when we calculate EWMA, it's going to be this lambda times this number right here, plus 1 minus lambda times the value in the same column right above it.
I think that's where I've been going wrong.
See, in order to calculate B, or any of the column in EWMA, is going to be, one of the answers comes from here, and the other answer comes from the value right above it in the same column. That's the difference with EWMA. All right? So it's this one here and this one here. This 270, yeah, this is a good problem. Where did this answer come from? Where did that 270 come from? It came from doing, well, let me figure out what this is first. 0.4 times 400 plus 0.6 times 270. Okay, so here, I just did this, and I'm getting 322.
That's what I got.
Okay, you got that? Okay, good. So according to what we just did, explain to me where this 270 came from.
For that, we would do 0.4 times 300, and then plus 0.6 times 250.
Very good, very good. Which 250 are you looking at, the left one or the right one?
The right one.
Exactly. Because see, when we get to EWMA, it's looking at what's going on there and what's right above it. See, that's the difference with EWMA. EWMA is going from this column to this column, whereas WMA and SMA are all just dealing with just this column right here itself. Now, one final thing we didn't, now let's say, oh yeah, so suppose I leave out the, suppose I put in SMA. So we have WMA, SMA. Now this acts just like a WMA in terms of the window size. So the window size is still 3 here. But this first answer is still going to be NA for the same reason as we did before. because I'm going to be plotting what the answer right here is going to be based on these first three right here. It's going to be in the middle of the window. But how do I get this answer? Let's say this is C. So how does this differ than what we did with WMA? How do I get this answer right here?
For this, don't you would do like 300 plus 400 plus 150 and then divided by 3?
Almost. Very good. And this is, you have the right idea when you say add them up and divide it by 3. So notice how in this case, I don't give you any fractions, like the 1/2, the 1/6, right? Because literally I'm just going to add them together and divide by like 3 here. But see this C right here. So if that's the middle, then what other two numbers go with it?
Oh, 250 and 400.
There we go, right? So it's the same idea in terms of SMA. It's just that if that's 3, and this is my answer right here, then the middle there suggests that the one on top and the one on bottom makes this be in the middle. So we're going to have C equals that 250 plus 300 plus 400, and then all of that divided by 3. So let's see what this is. Okay, what did you get on that?
I got 370.
Okay, I'm getting 316. Wait a minute. I could be wrong. Let me see. Wait a minute. 250 plus 300 plus 400. Okay, I'm getting 316. Do it one more time. I'm getting 316.
Okay, I got 360 now. I think I put in the first number wrong. The first time.
But do you see here how you say SMA, which is going to be average, then the WMA, which is going to be this fraction times this other fraction times this, right? And then EWMA is you're using the lambda with one of these numbers, and then the 1 minus lambda with the number right above it. So on your cheat sheet, when you're doing your cheat sheet, you may want to put like a sample data set or something, and then just say, you know, SMA3 or whatever, and then just over on the side, just sort of, you know, give yourself a hint about how to get it. And then WMA, you know, give yourself a hint to figure out how to get it, right? And then the same thing with EWMA, so you can have that idea going on.
Yeah, that makes sense. Thank you, Professor.
Okay, all right. Well, again, I'll have office hours next week, Monday and Wednesday. So if you have any questions or anything, just email me and we can try to set up some more office hour time.
Okay, I'll try. I'm gonna try on Wednesday to do that.
Okay, all right. Well, just drop me an email.
Okay, thank you.